This isn't science fiction. This is something you can test yourself. And once you do, you'll start questioning everything they've told us about space. We've all been told that the moon reflects sunlight, right? That's why it glows at night. But here's the issue. If the moon is just a big rock bouncing heat from the sun back to us, then its light should at least be neutral or slightly warm. But that's not what happens. Instead, multiple tests have shown that objects in direct moonlight are actually colder than objects in the shade. That makes no sense under the globe model. How can a light source lower temperature? Does the moon actually have its own unique effect that we've never been told about? It gets even crazier. If you use a digital thermometer and measure two objects at night, one under the moonlight and one in the shade, the one in the shade is actually warmer. And this isn't just by a fraction of a degree. Some tests show differences of 5 to 10 degrees Fahrenheit. And here's the kicker. If you take a magnifying glass and focus sunlight onto a single point, it gets hotter. That's expected. But if you do the same thing with moonlight, the temperature actually drops even more. How does that make any sense? This can be tested by anyone, anywhere. Grab two identical objects, place one in the moonlight and the other in full shade, and use a thermometer to measure the difference. You'll see that moonlight is actually cooling whatever it touches. If the moon is really just reflecting the sun's light, then this should be impossible. The only logical conclusion, the moon isn't just reflecting sunlight, it's emitting its own unique light, one that has the opposite thermal effect of the sun. And if that's true, then what exactly is the moon? Is it really a rock orbiting Earth, or is it something completely different from what we've been taught? If moonlight is truly cold, then what else have they lied about? Why is this simple experiment never taught in school? And most importantly, what is the moon really? 62 degrees. This is in the moonlight. 60 degrees. I gotta keep it right here to see it. 59 degrees. Now we're gonna move over to the other side of the car, where the moon is not on. We're just moving. And we're gonna try this again here. It's now reading 65 degrees. Okay, now just move the laser, and I'm moving the laser to where the moonlight is shining, and it rapidly drops. Okay, move it back down. I'm going to move it back down here. Goes back up. Jump back up. 65 degrees, and back on the hood where the moon is shining. It's almost a 10-degree change. We're going to do this on another car over here. We're going to go out of the moonlight. It's a dark car. Moon's there. It's a dark car. This is out of the moonlight. 66.6 degrees. We're going to move it into the moonlight slowly. And it's dropping dramatically. Same kind of paint on both the hood, or the trunk and the side of the car. 55.8 in the moonlight. Moving back to the side. Jumps up to 66 degrees. Yeah. That's proof that the moon is a cooling influence to us. It's a cooling light. It's a cooling light, not a heat light. 55 degrees in the moonlight. 65 degrees out of the moonlight. 10-degree difference. 10-degree difference. Oh my dear Tap Tap. Another secret kept from us.